Dr. Faden is expected to present today, isn't he?
Yes, Dr. Faden is the instructor.
I'll excuse myself for the time being, and when I get a chance, I'll be back in. Okay, thank you.
Dr. Vladimir, can you hear me?
Yes, Ms. Masuma, please.
Hi, I was thinking to create a barcode for our questionnaire.
Okay, that makes sense. If it will be easier for the students to scan, so.
And they start the example. So this is needed for next week. So should I go ahead and do that?
Definitely, yes. If you
Okay.
need any help in this regards, please let me know. If you
Sure,
can do it on your own, even better. Thank you in advance.
Thank you.
Hello, dear colleagues.
Hello, Dr. Faden, welcome.
Thank you, Dr. Vladimir. Hello to everyone.
Hello, everyone, Dr. Faden and Dr. Vladimir and all colleagues.
I believe in 1 minute we can begin, Dr. Vladimir, so we can utilize all the time.
Definitely, Dr. Faden, feel free whenever you are ready. Feel free to start. The session is being recorded, so for those who are maybe late for a minute or two, they will be able to.
I am ready.
Yeah.
I'm ready. So let me share my screen, and we can begin. Okay.
Dr. Vladimir, Dr. Faden, just a little note or a request, actually. Some of us do have lectures at 2 p.m., right? And is there a possibility going forward to finish maybe 5-10 minutes earlier, just for us to be able to freshen up and get to our classes? It would be appreciated. I mean, I don't want to miss out on on the last 10 minutes, as simple as that. So if there is a way to accommodate, would be appreciated.
Look, the issue is that that particular lecture initially was divided in 2 sessions, and I had, to deliver one. So I'm combining 2 lectures in one, 2 training sessions in one. Plus, we lost 15 minutes from the meeting. So I doubt that we can do that. We can definitely give it a try, but I cannot promise anything, Dr. Whale. Okay.
Yeah, that's appreciated. But anyways, if we could put it in mind for the coming sessions, I know there is plenty of more coming sessions. So it would be great if we could take that into consideration when planning them, so that we don't want to. I don't want to cut the last.
If I may add something, Dr. Weil and Dr. Faden, simply these sessions are being recorded. So after each session, we prepare and upload the recording into the archive. So later, each one of us is able to actually access the file and watch the whole session or the part that you missed. So maybe this could be one of the solutions for this issue, especially in this occasion today.
Exactly. So let us begin. Basically, the training session today refers to 2 statistical techniques. The first one is descriptive analysis, and the second one is about correlations. So we will first begin with descriptive statistics, and then we will proceed with the correlations. So I will focus mainly in how we use SPSS to get those descriptive statistics and correlations. Usually, I devote a lot of time in explaining also the theory, but now, because we have limited time, I will go through the basic concepts, the theoretical concepts, and then I will focus more on how we can use SPSS to get those statistics. So, learning objectives for today related to descriptive statistics. We are going to learn how to obtain descriptive statistics using SPSS. All descriptive statistics can be categorized in 3 groups. the measures of central tendency, measures of dispersion, and the shape of the distribution. We will also add one more element, cross tabulations. So here you can see that we have different types of descriptive statistics, such as the mean, the median, the mode, sum, etc. In general, the idea is you calculate descriptive statistics for two reasons. The first reason is you want to get an insight about your data. It's a first, feeling about your data. You get some first, understanding about your data, your variables, and this is something very important. Now, rarely, a good publication will contain only descriptive statistics. Usually, you need to proceed by using bivariate or multivariate data analytical techniques. But as a starting point, you should always begin with descriptive statistics, especially when you are describing your sample, such as the gender, the sex, the occupation, the age, some demographic variables at least, should be reported in any paper, and in that case, you need to use descriptive analysis. The second reason is that in order to proceed with bivariate or multivariate data analytical techniques, you need to check for certain assumptions, and especially each technique has its own assumptions. So in some cases, you might need to check if there is a linear association between the data, or you might want to check if the variables are normally distributed or not. Because in statistics, first you check for the assumptions of each statistical technique you want to use, and then you proceed with the selection of the appropriate statistic. For example, we have parametric statistics and non-parametric statistics. Parametric statistics requires certain assumptions to be confirmed. And one important assumption is the assumption of normality, which we will discuss further in this lecture, and we will see how we can check variables if they are normally distributed or not. So we have the measures of central tendency, the measures of variability, and then we have the measures which are explaining the shape of a distribution. So here, very quickly, we can see some measures of central tendency. Mode, median, and mean. Mean is the most prominent statistic that researchers are using. Then we have some measures of variability, frequency distribution, basically if the variable is nominal. We have range, we have standard deviation. Researchers mainly use standard deviation to report the dispersion of the data within a data set. And then we have measures which try to describe the shape of a distribution. The first one is the skewness. Symmetrical distribution or normal distribution has a skewness of 0, here as you can see, where the mean, median, and mode are identical or very similar to each other, very close to each other. Then you might have I'm trying to make it full. Yeah, now much better. Then we have the positive skewness, where you can see here that the distribution has many high values on the long right tail of the distribution, which this means that there are some extreme values, high positive values, extreme values, which are pulling the mean on the right direction. And then you have the median always in the middle. And then you have the negative skewness, which means the statistic of skewness is negative, which means that there is a long tail on the left of the distribution here, which means we have some low values, extreme low values, which are pulling the mean on the left side of the distribution. Another statistic we use to describe the shape of a distribution is kurtosis. Now, kurtosis, here you can see in the middle the mesokirtic distribution is another word for normal distribution. and it has a value of the kurtosis statistic of 0. Now, if the kurtosis statistic is positive, then we have a leptokurtic distribution, which means the distribution has a higher peak than the normal distribution, as you can see here, the red one. Or if the value of kurtosis statistic is negative, that is the case here, we have a flat distribution when it is compared to normal distribution. And this is called platykirtic. By the way, those are Greek words. In Greek, we say leptokirtiki, mesokirtiki, platykirtiki. So those are Greek words. What else you need to know? I will give you all these slides, but I want to highlight on the most important things due to limited time. So the next important thing that you need to know before you start calculating descriptive statistics is the scale of measurement of the variable, because based on the scale of measurement of the variable, you need to calculate specific statistics. For example, when you have a nominal scale, an example could be what is your gender, then you basically need to calculate percentages or frequencies. When you are using ranking questions, in other words, the scale of measurement is ordinal, you should calculate the median, and then you will be comparing the medians for each of the values of that variable, of what is being ranked. When you are using interval or ratio scale, which in SPSS, this is recorded as scale measurement, level of measurement, then the most appropriate statistic that you should report is the mean for both, and the standard deviation, so you can give an indication about the level of dispersion in your data. Also, another important thing that you need to know about descriptive statistics is that we use them to identify outliers. Outliers are values which are either extremely high or extremely low, abnormally high or abnormally low. And this can, when you have outliers, this can, create some issues in your distribution of the data. And it can, it can definitely affect the mean, because outliers are being affected by the mean is affected by extreme values. Whenever you have many extreme values, a better statistic to use is the median, because the median is not affected by outliers. Now, SPSS is using the 1.5 plus interquartile range rule in order to identify the outliers when we use specific box plots. We will see, we will have an example of a box plot, and we will see how SPSS detects these outliers. Now, this 1.5 plus IQR rule is using the quartiles, and for anything below the first quartile minus 1.5 the interquartile range, and anything above Q3 quartile plus 1.5 interquartile range are being reported as outliers. Q1 is the first quartile, which means that it divides the data in 25% low values and 75% high values. Q2 is the median, which is the value in the middle of the data set when you put them in ascending or descending order. And it divides your sample into 50% on the left and 50% on the right. Q3 is the quartile which divides your dataset in 25% high values and 75% low values. We will use SPSS, the descriptive statistics function, and we will see also how we calculate the Q1, Q2, and Q3. Also, the interquartile rates basically is the range Q3 minus Q1. Okay, what else from here we can use? Okay, with this, we already said that for scale variables, we should use the average, the mean. We should not include the median unless you have some, extreme values or outliers. Then the median becomes more robust statistic. Definitely include standard deviation because this is the measure of dispersion. And if you have, many high values, several different values, then, for example, age, you could report the mean value and the max value. If you have, for example, a Likert question from 1 to 5, there is no need to report the mean or the max. We know the mean is 1 and the max is 5. It doesn't make sense. Now, this is an example about how you should report descriptive statistics for interval or ratio scale. As a matter of fact, this one is ratio scale. Here you can see we report the means, the averages, and the standard deviation. It's always to put them in descending order so the viewer can see which is the most important, let's say, characteristic, especially when those items are measuring the same construct or somehow are related, and you can have meaningful comparisons. And always don't forget, if it is interval, to mention the scale exactly below the table. So 1 means poor, 5 means excellent, so 4.5 means it's very close to excellent. Always you should report the unit of measurement. If it goes ratio, for example, let's say age, then you should report here that you are talking about years, okay? For categorical data or nominal data, we said we should include frequencies and percentages. And usually the mode is very obvious because it's the value with the highest frequency of occurrence. So frequencies or percentages could be recorded, could be reported. This is an example of a nominal or categorical variable, how we report with percentages. Also here we could have put them in descending order, so 56.8 should be the first, and then we go down, so we give an indication which is the most preferred, and the last item should reflect the least preferred. And then the last thing is cross tabulations. Now, this is an example of a cross tabulation. We will use SPSS in order to calculate cross tabs. Here we are trying to cross tabulate two variables. This is a 2 + 2 cross tab. We have here the occupational status, white collar, blue collar. We have the type of buyer, if he's a buyer or non-buyer. And then inside each of the cells, we include the frequencies or the number of cases which are white collar and buyers, 152. White collars, non-buyers are 8. Blue collar and buyers are 14. And blue collar and non-buyers are 26. And you can calculate, the percentages within this table per combinational group. And also, you could calculate the totals either vertically or, horizontally or vertically. Okay, that was a very brief and quick, introduction to the different types of statistics. Now, quickly, we are going to move into SPSS and start working on some specific scenarios. Again, I'm going to give you this handout about SPSS tutorial number 2. We have here a table which presents data for with Kuwaiti Airways. So basically we have two variables. One is year, and then passenger in thousands. In thousands means that we have to add here 3 zeros. So basically the number should look something like that. This is for interpretation purposes. Always pay attention on the unit of measurement and on the scale. Okay, so and we would like to calculate some descriptive statistics, not of course for years, but for passengers, because this is meaningful. So what I already did to save time, I already entered the data into the SPSS. So in the variable view, as you can see here, I already defined the two variables, year and passengers. Both of them are scale. As a matter of fact, both of them are ratio. If you don't know what I'm talking about, I highly recommend that you revisit my first lecture titled Questionnaire Design, where we fully explained all the scales of measurements. So I correctly defined all the two variables. I put them as numeric, no decimals, no need to put labels or values because it's very straightforward, and I don't have any missing values, so I didn't select any missing values. Then you go here down to data view and you input your data. You could easily, if you have Word here, you can select, copy and paste. And you can paste the data here into the cells like you do in Excel, from Word to Excel. So in order to calculate the descriptive statistics, we need to use the function analyze descriptive statistics and frequencies. So we go to analyze descriptive statistics frequencies here. We click OK, and we need to move in this window here the variable that we want to calculate the descriptive statistics. Basically, we care about passengers. So we select passengers, we click here, and the variable is transferred on this window. There is no need to display frequency tables because the variable is ratio. We use frequency tables if the variable is nominal. For example, what is your preferred color? And then we will get the percentages and the frequencies for the preference of colors. But here it doesn't make sense because it's ratio. So we untick this. We go to statistics, and here you will see that SPSS is providing you all those categories that we just briefly explained and discussed in my introduction using the PowerPoint. We have measures for central tendency, we have measures of dispersion, and we have measures which are describing the shape of the distribution, skewness and kurtosis. And we have quartiles. So let me quickly select some, means that we want SPSS to add all the passengers in all those 8 years. Also, let me select quartiles and a couple of, dispersion, statistics, skewness, and kurtosis. Once you do this, you click continue, and then you click OK. As you will see, SPSS will open a new window here. That's a new window, the output window. And we said that those two things are being saved differently. Okay, the data matrix here and the output window. So here we have SPSS immediately calculated for us the first statistic. It tells you what's the number of cases and refers to the valid number of cases. Here it tells me that I have 12 missing values. I don't have any missing value. Don't know why I cannot switch. Here you will see that these are considered by SPSS as missing values because I entered some values here on these other columns. SPSS thinks that these are missing values, but basically I don't have any missing values, as you can see. Don't know why it's not working correctly. So going back to the output, we have 8 valid cases. SPSS gives us the mean, the median. Mode doesn't make sense because there is no value which is repeated. Standard deviation, variance, all those statistics that we just discussed automatically with just clicking, selecting the appropriate techniques and just clicking. We see that there is negative skewness here. We see that there is positive kurtosis. So we are talking about a distribution which is leptokurtic and negatively skewed. we have the range, the minimum value, the maximum value, the sum of all travelers here, and the percentiles, the 25, the Q1, the Q2 is 50, and Q3, 75. As we said, Q2 should be exactly the same as the median. And as you can see, this value here, 5199, is exactly the same like the value of the median. Okay. So this is a first calculation of descriptive statistics. Now, let's try to create some graphs. The function is graphs, lines, simple, define, and you will see how we can get those graphs. So we go to graphs. We want to calculate a line graph. We select simple, define, and here we move here into the category axis, and the variable that we want the graph to be created, we click in other statistic, and we move it in the variable window here. And then we click in OK. SPSS will automatically create a graph for you. If you would like, to elaborate more in this graph, you can double click on that image and you can change the titles or do other characteristics or other statistics. The next we would like to create would be a bar chart. So we go to graphs, bar, simple, define. And again, we put here in category axis, we select other statistic, we put passengers here in the variable, we click OK, and we have our bar chart. Or we could also create an area chart. So we click in area, simple, define. Again, same process here in category axis. Other statistic, we move passengers. OK. And we have the area graph. Now, the last thing that we could show here is to try to plot the normal curve on histogram. So what we have to do is go to analyze descriptive statistics and frequencies. And basically, we will use charts and histograms, and we will tick the show normal curve. That is, you might want to do that to see how the normal distribution curve looks like. So analyze descriptive statistics, frequencies. Always we want to do this for the passengers. So we go to charts. See, frequencies, charts, histograms, yes. Histograms here. And here we can tick this option, show normal curve on a histogram. So when you click, something wrong with my mouse, guys. Let's do it one more time. My mouse is very problematic. It clicked also paste. When we click paste, remember we enter the syntax editor. We don't want to do that here. So this is the histogram I was talking about, that you could see the normal distribution curve. Now, it seems that from this histogram, we have here an outlier. How we can detect outliers? We can go to Analyze, Descriptive Statistics, and Explore. When you go to Explore, you move passengers into the dependent list, because this is the variable you care. Then you click in Plots, here you can have, you know, the histogram, and you can also do some normality plots with tests. This is when you would like to check if the variable is normally distributed. Let's also discuss about it now. So we can tick normally plots with tests, continue. And in statistics, we can select the outliers. We don't care about descriptives, we already calculated descriptives. So in statistics, you can tick outliers, continue. And then, okay. So now you will see that SPSS calculated a box plot, and in that box plot, it identified that case 1 with this asterisk, which refers to 2000, close to 2000, should be considered as an outlier. As a matter of fact, it's a very low outlier. An outlier, as we said, is a value which is far away from all the other values, abnormally far away. Now, it's up to you if you would like to delete or not these outliers, because sometimes outliers there might be some valid reasons why they exist, and might give some, you know, important explanatory power when you discuss, but it depends. It depends on the variable, it depends on the value of the outlier, it depends on the conditions. It's up to you to further investigate. So if we go, you know, to back to the data metrics here, we will see that case 1 for passengers here, this value here is considered by SPSS as an outlier by using the rule of thumb that we discussed previously, 1.5 plus the interquartile range. Okay. Now, the next step is to calculate some statistics, descriptive statistics between two nominal variables. So here in table 2, we have the following variables, SOP and milk brand. So table 2 presents sales data for milk brands X and Y, both from SOPs A and B. So I need to input the data into the SPSS, and basically I'm trying to identify if there is any consumption pattern of specific milk brands bought by specific types of SOPs, SOP A or B. So what we have to do is we go again to the variable view. We define the two variables, SOP and milk brand. Both of them are nominal, not scale like previously. In other words, we have words, brand names of milk and names of SOPs in our case. Still, we have to put everything as numeric because we want SPSS to calculate some frequencies. And we have to define the values. So I defined one as A for the SOP and 2 as B for the SOP. And also I defined milk brand as 1X and 2Y based on the guidelines of the scenario. So what we have to do now, we would like, first of all, before we do some crosstabs, we would like to calculate some descriptive statistics for nominal variables, not for ratio like what we did previously. So analyze descriptive statistics frequencies. Analyze descriptive statistics frequencies. SPSS kept our previous selection, so by clicking on reset, you eliminate everything. And now you want to move SOP and milk brand on the right. Now you need to tick this box because we are talking about nominal variables. So we want SPSS to display frequency tables for those nominal variables. If I click statistics, it doesn't make sense to select any of those because these refer to quantitative data, not qualitative data. Remember, we have names of SOPs and brand names of milk. So nothing from this, it will be a big error. And if you click in charts, you can calculate some pie charts. So continue and OK. So now we see that we have 20 valid cases. And we also see that we have for SOP A has 11 frequency and 9 SOP B. Also, you can see the relative percentages. 55% of the sample are SOP A and 45% of the sample are SOP B. And you can see that the milk brand is 50% X and 50% Y. And here you could see the pie charts as requested for SOPs and for milk brands. The next step is to try to combine those two variables in order to see if there is any specific preference from the consumers when they buy milk Y or X from a specific SOP, A or B, if there is any specific preference. So analyze descriptive statistics cross tabs. The bar here disappears. You can do it even from here. Analyze descriptive statistics cross tabs here. You see, I can access the analysis menu not only from the data matrix, but also from the output viewer here. Cross tabs. So we are going to move SOP to row and milk brand to column. It doesn't matter, you can do it either way. Cells, we can have the totals here. You could also put percentages per row and column. Continue. These are statistics for measuring the association between the two variables. We're not going to do that. And click OK. So now SPSS is giving you this table. Let me ask a question. Do you see any specific consumption pattern of selecting a specific milk brand more from a specific SOP? Can anybody understand this table here? Okay, I assume that nobody can answer the question. So as you can see here, we have.
Sorry.
Yeah. Yes.
Just my interpretation, Dr. Faden, it seems that consumers, they tend to purchase more milk brand X from shop A.
Correct, because you have this 8 here value, correct?
Yeah, I'm looking at that 72%, and vice versa. So brand Y is mainly purchased from shop B. That's
correct. Correct. This is the correct interpretation, Dr. Walid, and thank you for your answer. You see that there is a trend. Most consumers buy milk brand X from shop A and milk brand Y from shop B. Also, you can see all the statistics inside the combinational statistics and the total percentages and statistics. Now, in order to find out if this preference is statistically significant, you need to conduct a chi-square analysis, which is measuring the association between two nominal variables. We were not going to do it right now. The next and third and last thing that I would like to discuss with you in terms of descriptive statistics is when we are trying to explore the relationship between an interval or ratio variable with a nominal variable. So here we have in table 3 the two variables, minutes and gender. So table 3 presents the time in minutes that 15 respondents, male and females, used their mobile phones to talk during one day. So we need to code our nominal variable, gender, so 1 for men, 2 for women. And of course, minutes does not require any coding because 15 minutes, for example, here means that the guy, the person, the man, because this is a man, speaks 15 minutes over the phone. So here the research idea is using descriptive statistics. Can we, for example, identify who talks more in the phone, men or women? So what we have to do, we need to use the explore function. If you remember, we used it previously to identify the outliers. We could also do that also for those two variables here. So analyze descriptive statistics, explore, and we need to put minutes in the dependent list and gender in the factor or grouping list. So analyze descriptives, explore, reset. We put minutes in the dependent list, and we put gender in the factor list. So we are telling SPSS, create two different groups, men and women, and calculate descriptive statistics about the minutes variable. Now in statistics, you can also select outliers. And of course, we want the descriptive statistics per group to be calculated. Continue. Plots. Again, we can have normality plots with tests, which we didn't explain in the previous time. We will explain it now. And also we can have some histogram. Continue. Anything in options? No. And OK. So SPSS is giving me the descriptive statistics per gender. So here, the first section of the table on the top gives you statistics about males. And the second gives you the descriptive statistics about females. So with a very quick look, we can see that women talk more in the phone compared to men. So we have 20 minutes, the average for women, and 18 for men. Now, this trimmed mean 5% is when you exclude 2.5% of very low values and 2.5% of very high values. So it's a statistic by SPSS, which is trying, to give you a more reliable mean, because this, we said that the mean is affected by extreme values. So it is trying to remove the low 2.5% and high 2.5% of the values. But again, even in trimmed mean, you will see that women have a higher trimmed mean, 21.94, compared to the men. Also, the median of women is higher, 24 the median and 17.5 for the men. We see the minimum, the maximum, and of course, skewness and kurtosis statistic. Here is the interquartile range for both variables. Now, tests of normality, this is something which we need also to address. Apart from, visually examining the distribution of frequencies or the box plot or skewness and kurtosis statistics to understand if the variable is normally distributed or not, we can use Kolmogorov-Smirnov test for large samples and or Shapiro-Wilk test of normality for small to medium samples. And we need to check this sig value here for the Kolmogorov-Smirnov, which is 0.198, and this sig value here for the Shapiro-Wilk test. If the sig value of the Kolmogorov-Smirnov test or the Shapiro-Wilk test is higher than 0.05, then this means that the variable is normally distributed. So the threshold point is 0.05. This is also called alpha level. So in our case here, we see that minutes for men and women, those two groups, this variable is normally distributed. Why? Because the sig value of both Kolmogorov, Smirnov, and Shapiro-Wilk are higher than 0.05. If we would like to examine the data, yes, you see that skewness and kurtosis statistics are quite close, to zero, and especially for women are also very close to zero. Also, another way to look at it is the mean. Is it close with the median? Yes, the mean is close with the median, 18, 17.5 here. And what about women? 22 is close to 24. So this is another way to check if the variable is normally distributed. Now, checking the histogram of men, we see this guy here who is talking 40 minutes. That we need to see if it is an outlier or not, as per the rule we explained previously. And similarly, we have a woman who speaks 10 minutes compared to the other women. Of course, we have not many cases, so we cannot really evaluate if the variable is normally distributed or not, because we have only, I remember, 8 cases, or 10 and 10, 20 cases. So you need much more cases to be sure. Now, if we compare the box plots for men and women, you will see, I'm delivering a presentation. 2:15, we said. Okay, thank you. Thank you. So here we see that the box plot for men is much lower than the box plot of women, which means that men talk less than the men. The men talk less than women. And also you will see that SPSS identified case number 4, which is the value of 40, that guy here, as an outlier. So 40 has been identified as an outlier by SPSS, while we don't see any outlier for women. So 10 is a valid value, is a value which is not considered to be as an outlier. Okay. Let's quickly move 30 minutes to a correlation analysis. Now, some very brief introduction about correlation analysis. First of all, we are going to discuss, before I proceed, do we have any questions about descriptive statistics?
All good. Thank you, Dr. Freitan.
All good, no questions. So let's proceed with a correlation analysis and give an idea about it. So the first thing is, in terms of learning objectives, we're going to discuss what we mean by the term association. We will discuss about the underlying assumptions in order to use the most appropriate type of correlation, parametric or non-parametric correlation. And hopefully, if we have time, we will proceed with the calculation of Pearson, Spearman, and Kendall-Staubeck correlations. Pearson correlation is used when the assumption of normality and linearity are being confirmed. Spearman is a non-parametric equivalent of Pearson, which means if you don't have normally distributed variables or a linear relationship, then you should use Spearman, and Kendall-Staubeck correlations should be calculated when your data are ordinal. Let's very quickly discuss the characteristic to measure 3 things. First is the absolute size or the value of the correlation coefficient. Then we have the direction, if it is positive or negative. And then we have the statistical significance. of that correlation. So we need to check the p-value of the correlation coefficient. And if the p-value is less than 0.05, then this is a good thing for us because this means that the correlation coefficient is statistically significant. Remember, for Kolmogorov-Smirnov test, we wanted the p-value to be higher than 0.05 in order to claim that the variable is normally distributed. So it's the opposite thing here. In general, you want the p-value to be always less than 0.05 or 0.01, because this will mean that you have a statistical significant result. A statistically significant result is a result which does not depend on luck. In other words, you found a true correlation, a true association between the two variables. By the way, here we use two variables. Previously, for descriptive statistics, we used only one variable per time. Of course, we could use also two when we wanted to do some explore function or calculate some crosstabs. But here, you need to have always two variables, not one, not three or more. Only you have calculation of correlation coefficient between two variables. The idea of association is you cannot identify or claim that there is a cause and effect relationship between the two variables. This is something important to know. In regression, you could claim causality, but in correlation, you cannot. Basically, what you are trying to investigate is how those variables are moving. For example, when one goes up, what is happening to the other one? If one goes up and the other goes up, then we have a positive correlation. If one goes up and the other goes down, then we have a negative correlation or association. Or if one goes down and the other goes down, then we have a positive correlation. So when they move into the same direction, both variables, then we have a positive correlation. When they move in a different way, one goes up, the other goes down, then we are talking about a negative correlation, So those three things.
Dr. Faden,
yeah.
It's like
Yes.
it's like before when we took it in mathematics before. It's like plus is basically plus, minus is actually plus, and so on and so forth. It's like plus
Correct.
minus is minus, and minus plus is actually also minus. So it's the same concept.
Correct. Exactly that. Some people make the mistake. They think that if one goes down and the other goes down, it's negative, but it's not. It's positive because it's exactly what you said. Now, also, the correlation coefficient takes a value from -1 to +1. If it is close to +1, it is very strong correlation. If it is close to very strong positive correlation. If it is closer to -1, it means there is a very strong negative correlation. Of course, you might have correlation which is close to 0, then you have to say that the variables are not correlated at all. Now, the first assumption of Pearson correlation coefficient is a scatter plot, a scatter diagram, where here you can identify if the variables are linearly associated. So in this example here, yes, we could fit a line here among the data to claim that the two variables are linearly associated. So the assumption of linearity is being checked by creating a scatter plot, like the one I showed you previously. The assumption for normality can be checked by calculating descriptive statistics, as per my analysis previously, if the mean, median, and mode are very close, if the skewness and kurtosis are close to 0, or by using the Kolmogorov-Smirnov test, where you would love to see a p-value which is higher than 0.05, because this would mean that the variable is normally distributed. And of course, keep in mind that for Pearson correlation, variables should be measured in the interval or ratio scale of measurement, not nominal, not ordinal. So those are the three very important assumptions that first you need to check and then proceed accordingly. If those three assumptions are confirmed, then you can calculate Pearson correlation. If those assumptions are not confirmed, for example, you don't have, let's say, linearity or normality in one of the variables or in both of the variables, then you should use the equivalent of Pearson correlation, which is Spearman correlation for no normality or no linearity. Anything else? How you report the Pearson correlation. Here you can see how you report it. R stands for the Pearson correlation minus 0.78. So here we have a negative, quite strong correlation because it's close to -1. You need to report the cases, the number of cases, 426, and you need to report the p-value, as we said, of that number here. And since the p-value is 0.0005, this means good news that a true correlation exists between the two associated variables. Why? Because the p-value is less than 0.05. So this correlation is a true finding, and the true correlation exists between the two variables. Okay, always keep in mind that it does not demonstrate cause and effect. In other words, you cannot claim causality, that one variable caused the movement, a specific movement to another variable. It is just measuring the if they are associated, if they are related, if let's say they are moving in the same direction or not in the same direction. Okay, very quickly I explain the theory. So let's go to our handout and use SPSS to calculate some correlations. Now, we have here two variables, discount and unplanned purchases. So table 4 presents the discounts for 10 different products and their unplanned purchases. And we would like to check to see if there is any correlation between the amount of discount and the unplanned purchases that the consumer made. An unplanned purchase is a purchase that the consumer did not think of buying before he goes to the supermarket, let's say. But when he went to the supermarket and he saw, let's say, the discount, he decided to buy because of the discount. But this because, we cannot claim it here, because means causality. So we just want to see and measure if there is any correlation between those two variables. For causality, we could calculate another statistic, regression analysis. In a regression analysis, you can claim causality because you have dependent and independent variables, and you can claim that the dependent variable is the cause on the dependent variable. So here, losing the bar. What is the bar? All right. This is an issue here. All right. So we need to use SPSS to input those two variables and define the variables first, and also input the values. So we go to SPSS. As a matter of fact, this one we don't have here. We have to open that file. Correlations. All right. So as you can see here, we have the two variables, discounted and unplanned purchases here. Both of them are scale. Both of them are ratio, as a matter of fact. And we also inserted the data of discounted and unplanned purchases in the data matrix. So now we would like to calculate the correlation coefficient. But before we calculate for the correlation coefficient, we need to check the assumptions of linearity and normality. So to assess the linearity, as we said, we need to create a scatter plot. So graphs, scatter dot, simple scatter, define. And here I'm moving passengers to Y. Sorry, not passengers. We close this. Here, again, discounted and unplanned. Graphs, scatter dot, simple scatter, define. And we can put discount in Y and unplanned in X axis. And OK to create the scatter plot. So here SPSS gives us the scatter plot. By just checking the scatter plot, we can certainly identify some linear relationship. I double click in the scatter plot. I click on elements and then fit line at total. So we could see that, yes, we could fit a line between the two, the distribution of the values here, which means that, yes, we could use Pearson correlation to identify if there is any linear relationship between those two variables. So the next part, the next step is to check for normality. For normality, remember, we need to check the Kolmogorov-Smirnov test. Now, I will show you a different way that you can get this test from the previous time. Analyze non-parametric tests, legacy dialogues, and one sample KES test. So, analyze non-parametric tests, legacy dialogues, one sample KES. KES stands for Kolmogorov-Smirnov test, normality test. We click on that, and we need to check both variables if they are normally distributed. So we move both of the variables in the window here. We need to tick this normal distribution. It's already ticked by SPSS, and then we click in OK. Now we need to look for the p-value, which here is under the name sig value two-tailed. And you will see that for both variables, the sig value is 0.2, 0.2. The sig value of the Kolmogorov-Smirnov test for both variables is above 0.05. This is what we wanted, because if it is above, it means that both variables are normally distributed. So by checking the scatter plot, we confirm linearity. By checking the Kolmogorov-Smirnov test, we also confirmed normality. Therefore,
Dr. Faden, I just have a question. I'm sorry
please.
if I'm interrupting. Some researchers I saw they're using another test than KS. It's called Shapiro-Wilk test.
Yeah, I discussed it. I discussed it previously. Shapiro-Wilk is a better test if you have a low sample size.
Okay,
so
just for the
yes, the sample size. For larger sample sizes, the KS test is giving you a very good indication if the variable is not normally distributed or not. So if you have large sample sizes, let's say 100 and above cases, you could use Kolmogorov-Smirnov. If you have smaller sample sizes, 30, 40, 50, then you should use Shapiro-Wilk. Okay?
Great, thank you.
Welcome. So now we are ready to calculate the correlation coefficient. So we go to analyze, correlate, bivariate. Click on that. We move the two variables that we want to calculate. We need to tick which correlation we have to tell SPSS to calculate. Pearson, since we said we have normality and linearity. If data were ordinal, Kendall tau B. If we didn't have normality or linearity, then Spearman. Here you also have to decide if it's going to be a two-tailed or a one-tailed test. Now, what's the difference between the two? If you expect by theory or common sense a specific direction of the association between the two variables, then you have to select one-tailed. If you do not expect based on theory or based on common sense a specific direction of the association, so you don't know if it is positive or negative, then you have to select the two-tailed. In our case, we have discounted unplanned purchases. So basically, based on theory and common sense, we would expect that the higher the discount, the more the unplanned purchases. So when discount goes up, unplanned purchases also goes up. So that means that we expect a positive correlation. A positive correlation means that we have an idea about the direction of the relationship. Therefore, we should here select one-tailed test. And you tick this one, so SPSS can flag significant correlations. So SPSS can visually tell you which correlations are significant by putting some stars next to the correlation coefficient and which are not. Remember, significant correlation is a correlation which has a p-value which is less than 0.05. Okay, and here we have the results. You just need to check here the correlation coefficient, Pearson correlation coefficient, 0.982. It has two asterisks here, which means that it is significant not only at the 0.05 level, but at a better significance level, the 0.01 level of significance here. So we are talking about a correlation which is very close to +1. So it's very, very strong positive correlation and also statistically significant because the p-value here you see the sig value, the p-value SPSS tells you is almost 0.001, which is less than 0.05 and less than 0.01, which is a better threshold level for statistical significance. So you found something important, something that you can report, something that you can use it for a publication purpose when you find a statistically significant correlation. Also, sometimes non-statistical significant correlations, based on the way you explain them, can also be of value when you want to report them in a research study. So this is how we calculate the correlations. Now, we will also do one more, the Kendall tau B correlation when we want to correlate ordinal variables. The previous technique is excellent when you want to have, when you want to correlate variables which are measured in interval or ratio scale of measurement. When you have ordinal variables, you need to use Kendall's tau B. Ordinal, to remind you, refers to rankings. So here in table 5, we have 10 different paintings, painting A, B, C, D, etc. And 2 different rankings of those paintings. The first one by an art expert and the second one by the student of that expert. And we would like to see if we have a good professor here and a good student. In other words, their rankings, are they positively correlated? More or less, similar approach in ranking? or no correlated, or even worst case scenario, negatively correlated, meaning that when an expert places, a painting as a top quality painting, the student has a totally different opinion or idea about it. So we need to create, again, two basically variables. We don't care about the A, B, C, D. We care about the rankings here. So we create two variables, expert and student, and we have to input the data into the SPSS. So let us do it. Now, okay. So I already inserted the arts expert and student. Both of them are ordinal because we are talking about rankings. I also entered the data, the rankings of student and the expert. And here you could say that these are the paintings here, the paintings. So how we can correlate these two rankings by the student and the expert? We need to go again to correlate function by variate. We have two variables to correlate. We can reset all the previous options, and we need to insert in the variables window the two variables we want to correlate. You see, for ordinal variables, SPSS has a different here logo. And don't forget that we don't calculate Pearson because we have ordinal data. Pearson is for interval or ratio and for normally distributed variables and variables that are linearly associated. So we have to select Kendall's tau B because this is for ordinal. Now, any ideas? Shall we select a two-tail test or a one-tail test?
Two-tail, maybe.
Correct, two-tail, because we don't know the direction. Maybe we have a bad student or a bad professor, and we don't know if when the student, we would love to select one tail, but we cannot confirm that. We don't know if their two rankings are similar in their approach. Correct. Thank you for your for the answer. So two-tailed because we don't expect a certain direction of the association.
Doctor, what happens if I'm sorry. What happens if we select two-tail and it was one tail, or vice versa? Like, would the test actually identify that?
Look, basically, in most of the cases, it will give you the same result. In reality, practically speaking, it will tell you. But when you report, the findings in a paper, you need to clarify that and say that I use the two-tailed test because I don't expect any specific direction of the relationship between the two variables. Or you have to mention one-tailed if you expect a certain direction. But yes, so in most of the cases, it gives you the same. Not always, but in most of the cases, you will see the same result. Also, the same stands for Pearson or Spearman. And you could do that with the data. I don't think we don't have the time to do it. Instead of calculating Pearson correlation for discounted and planned purchases, we could have selected Spearman. Spearman is when we said there is a violation in one of the assumptions, normality or linearity. You would see that the Spearman and Pearson will give you, if not identical correlation, very similar correlation coefficient. If we have time, maybe we can do it. It can take only 1 minute. So I click OK here. I tick SPSS to flag significant correlations, and I click OK. So here we see this table here in the bottom. We see Kendall's tau B. And we see that we have 0.778 tau B correlation coefficient. This indicates that we have a good professor and a good student. The student is following the advices of the professor when he has to evaluate certain paintings, because the association, the rankings are positively associated. not 100%, not extremely well, but 0.7 is a strong correlation. Not very strong, but a strong correlation. It's close to +1. And the most important thing is that we have a statistically significant correlation. 2 stars here means that the correlation is significant at the 0.01 level of statistical significance. Since you told me to check about Spearman, let's very quickly, we have a couple of minutes, calculate the Spearman correlation between discount and unplanned purchases. So we go analyze. Correlate, bivariate, reset. Let's put here the previous 2 variables, and instead of Pearson, experimenting. Spearman, but also one-tailed, because we expect a positive correlation between the 2 variables. And click OK. Let's go to check. Now, that is different. It gave us RHO is the symbol for Spearman correlation, 1. Perfect correlation, while previously 0.982. As I told you, both correlations are very strong, positive, and statistically significant at the 0.01 level of statistical significance. 159. So I can give the floor to the audience. And I would like to see if there is any question from your side. We have 1 minute for questions. Any questions? No chat messages. Okay, Daniel has a class. So if there are no questions, just to summarize, today I explained to you how you can calculate descriptive statistics and correlation analysis. Descriptive statistics refers to a univariate data analytical method. Univariate means 1 variable per time. Of course, you could have cross tabulations, or you could use the explore technique to compare, 2 groups of people, like we did men and women, and how much time they spent on the phone. And correlations, you need to, first of all, to check for the assumptions of normality and linearity. If the variables are normally distributed, and if the variables are linearly related, and of course in interval or ratio scale of measurement, you should use Pearson correlation. If not, then you should use Spearman correlation, and for ordinal variables, you should use Kendall's tau B. If there are no questions, thank you very much for attending this course, and we will continue with those series. Professor Alper will take over, and I think the next topic is about factor analysis, if I'm not mistaken. Hope to see you again, and enjoy the rest of the day. Have a good day.
Thank you so much, Doctor.
Thank you, Dr.
Thank you,
Faden.
Dr. Faden.
Bye-bye.
Thank you, Dr. Faden.
My pleasure. Stop the recording.